Hello students, welcome to Physics Bouquet. Our topic today is thermal radiation and its properties. Dear students, as you know, there are three processes of heat transfer: conduction, convection and radiation. Here we will read about thermal radiation. Radiation in general is the process of heat transfer in which no intervening medium is required. That means medium is not required for the heat transfer in this process. And this process of heat transfer is by means of electromagnetic waves. Our electromagnetic waves includes gamma rays, X rays, ultraviolet rays, and our टेलीकम्युनिकेशन में जो यूज होता है वही रेज, मतलब आवर इंफ्रारेड रेज एंड अदर इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम में जो वेव्स होते हैं वो सब रेडिएशन में आते हैं. मगर ये जो थर्मल रेडिएशन है, ये थर्मल रेडिएशन it includes infrared rays. That means having wavelength more than the red light. That means visible light, as you know, it violet, indigo, blue, green, yellow, orange, red. In visible spectrum, red has the largest wavelength, and beyond red it is called infrared region, and those radiation which have energy almost including infrared are called thermal radiation. So radiation in general includes all the electromagnetic waves, but thermal radiation means it is infrared radiation. It is also called radiant heat. Another thing I want to say that no medium is required for this process of heat transfer, but if it is flowing through, if it is moving through certain medium, it doesn't mean that the medium is unaffected. Medium is affected whenever radiation passes through it. And our all material bodies like our sun, which is a black body, and it emits radiation. So material bodies, except at absolute zero, all material bodies radiate heat. Therefore, though medium is not required for heat transfer in the process of radiation, but if radiation passes through certain medium, then it may be affected. So this is about thermal radiation, and now we will switch over to properties of thermal radiation. And the most of the properties of thermal radiation are same as that of the light wave, which is also an electromagnetic wave. And as we know, light moves with a speed of, in vacuum or air, it moves with a speed of 3 into 10 to the power 8 meter per second. So it can travel through vacuum or empty space with the velocity of light. And the light and heat, they require same time to reach the surface of the earth. I can make an evidence of it. For example, when solar eclipse occurs, simultaneously heat and light both are eclipsed. Simultaneously there, the light, they require equal time to travel in vacuum. And second property, thermal radiation, it travels in a straight line. It travels in a straight line. Travels in a straight line. And like your experimental arrangement for light, light wave to pass through pinholes. If you take two pinholes and place them parallel to each other, if the pinholes are in a straight line, then light can pass from one side to another side. But if you inclines one of the pinholes, then the light cannot reach the other side. So it travels in a straight line. Then, like light, it undergoes reflection, refraction, interference, polarization, diffraction. All the properties of light are obeyed by thermal radiation. Here, an interesting thing I can tell. Archimedes was a great physicist, great scientist of Greece. He using thermal radiation, by reflecting thermal radiation, it is told that he was able to destroy or burn the ship of the enemy. If you take if you take a concave mirror, and at the focus of it take a source of radiation, source of thermal radiation, and in an estimated distance take another concave mirror, and he